Hi, this is dealing with an annuity or regular monthly savings. You could also term it as that. So here's a problem. If we put away $50 per month for 5 years and earn 4% interest, how much will we have at the end of 60 months? So I'm going to do this problem 3 ways. I'm going to use the spreadsheet, I'm going to use the TI calculator, and then I'm going to use the summation formula for geometric. And we'll show you why that it's a geometric. So if we go to the spreadsheet, I've set up the basics. You can pause if you want and put this together. But from here then, I have some principal amount. So let's say that we have our $50. So we're going to start off with our initial $50 at the very beginning. So in this cell here, I'm going to have equal to this cell. So that's where it comes from. So I can just change things up in this top part, and then everything else down here will change. So I'm going to have 4%. And so that would be 0.04. I can change that to a percent by clicking there, and then I have that. Now my additional monthly payment is going to be $50. So I can put that there. So my growth factor, and I don't always have to put this in, but I'm going to put it in for emphasis. This is going to be equal to, I get my initial $50 back, and then I'm going to add in this interest rate right here. But then I divide it by 12. I divide it by 12 because I'm just doing this for 1 month. If they're paying me an annual interest rate of 4%, I need to split that 4% into 12 equal parts. Then my new principal is going to be equal to this amount times this amount here. And then if I look at the additional monthly payment, that's going to be equal to this cell right here. Now I'm going to put a $sign in here so that when I fill down, it's always going to be the same amount. So when we do fill down, $sign means that it fixes it. So I can take all of these, and I should be able to, let's see, I don't want to fill down that first one. I need to do one more. So what happens is that my new principal is going to be equal to this amount plus my additional payment for that month. So at the end of 1 month, I'm going to be having my new interest, and then they're going to be paying me that extra $50 that comes from here. Okay, and then this growth factor, I want this to be the same too, so I should put a $sign in this. So when I fill down that, I still have 4% all of the time. So I'm going to fill this one down there. My new principal, I can just fill this one down. These I will not put $signs because this one and this one come from this row, so now I want this row and this row. So I do want this one to increment. So I'll bring that one down. That looks appropriate. And then my additional monthly payment is still going to be the same, so I don't want this to change. So if I click on here, it's E2 again because of the $sign. Now if I have this all set up and I'm on the PC, usually the PC works better with this. Sometimes the Mac does, sometimes it doesn't. And I'm getting these marks down here at 60 months. That's just because I have too much space in there. So if I look at 60 months, now I got to be careful here and decipher what all of this means. So how much do I actually have after 60 months? Well, looking at this, this right here is going to be my 59th payment in here. And I should say my 60th payment because I put one. Let me pause this for 1 second again. Now we really have to be careful what all this means, because if I go straight to this number right here, this may or may not be what I have at my 60th month. So let's work this out and see if we can figure this out. First of all, how many payments do we want to make? Well, we want to make 60 total. So there's my first payment at time 0. Here's my second payment, and that's in the 0th month, but not really because I'm putting that additional payment at the end of that first month. So really, my second payment is part of this right here. So that would be my second. This would be my third. And if you look at this month is 1, and at the end of my column, I have my third payment. So if I look at the 58th month, at the end of that month, which means that I'm starting my 59th month, that right there is going to be my 60th payment in. I really don't want to make any more because, you know, the numbers get off or whatever. Now, how do we interpret the rest of this? Well, what happens then is that I'm going to put this $50 in at the end of the 58th month, which is the beginning of the 59th. So at the 59th month, here's what I have with this $50. And then what's going to happen is that I'm going to earn the interest in that 59th month. And so this is what I would have after 60 months. I don't include this anymore because I don't want to make any more payments. So after 60 months, this is what I'm going to have. And notice that that's compared to this right here. This just has that additional one payment in. So I'd have to subtract $50 from this amount in order to get my actual amount. So really, this is my 59th term. Yeah, but I started at time 0, so this is my 60th month right here. So that's how much I'd have after 60 months. $3,326. Almost spot on. It's probably rounded in there. Okay, let's go to the calculator and figure that one out and interpret what that means and relate it to this. Notice that this is the 59th term, but then I've applied the interest rate. Or it's the 60th term, but I have to subtract off that extra $50. So now if we go to our TI calculator, first of all, we have to make sure we're in the correct mode. So we want to get this sequence mode right here. And then we go to y equals, and we put in this different information. So our n-min is what we're going to start with for our month. And so our initial time is 0. So I put that in. And then u of n is equal to, what we're going to be doing is just multiplying by the rate every time, or the growth factor. So it's going to be 1 plus 0.04 divided by 12. And what we can do then with that is multiply it by the previous term. So the previous term, and how we write the previous term, is u of n minus 1. And how do you get these different things? Well, u is by going second, number 7. And then the n, since you're in sequence mode, you can just push this one right here. There's the n right there. So it's your variable button on your calculator. And then what are we going to do after we apply that rate? Well, we're going to add in $50. And so that's the formula that we're going to have for u of n. So this means a term is equal to the growth factor times the previous term. That's what u of n minus 1 is. And then we're going to add 50 at the end. And then my starting value at time 0, that's what n-min is. U of 0 is going to be 50. So what we can do then is we can go to the table. And with the table, if you set this up so that you start at 0 and go on. So here's my $50 in the first, my initial payment. And then after time 1, I've put in another $50 and I earn interest just on that one $50 piece. Then after this time, I've earned interest on this $100.17, and then I added in $50 more, and so on. So what happens with the calculator is that if I go to the home screen and I find out what u of 59 is, u of 59 is $3,314.94. And then how does that compare to my spreadsheet? Well, and let's think about this. This is what happens after 59th month, but I still carry the interest rate through the 59th month, so I would still have to multiply this. Well, let's look at the spreadsheet here. The spreadsheet, this is the value we're looking at. We still have to apply the growth factor to get to my final amount. So after that 59th month, I have to multiply into the 60th month and multiply it by, oh, I got to use parentheses, sorry, 1 plus 0.04 divided by 12. And voila, there's my final amount. Now, this isn't exactly what we had before, but this got rounded. So it's either 3326 or else 3325.99. Okay? Now, the other way to do it is to go to the 60th month. And so if I go to the 60th month here, But what happens is that I'm going to make that last $50 payment, which I don't want anymore, because that would be 61 payments of $50. So what I'm going to do is, if I subtract $50 from this, I'm going to take it away, and then I get the same amount again, which is beautiful. So it's two different ways. I can go U of 59 and then apply that interest rate in that last month, or I can go U of 60, but I put in one too many $50 deposits, so I'm going to take it away, and then I'm going to get this value here. So that's the way I can do it with my calculator, and then corresponds very well with my spreadsheet and these values. You can compare those. Now let's use the summation formula, which now might seem much easier than all these little finagles that I have to do with the spreadsheet. So let's go back to the problem and see how we can do this. So if we do it with the summation formula, it's going to be a little bit different in our setup. And so how I'm going to do this is I'm going to take my first $50. If I take my first $50 and put it in, what's going to happen with that $50 is that I'm going to take it and multiply it by the rate, 0.04 divided by 12. And then I'm going to raise that 60 times, because that's going to sit in there for 60 months. That very first $50 is going to sit in there for 60 months. So in other words, that's that $50 right there. 60 months, it's going to sit in there the whole time. If I do this $50, it's going to sit in there one less month to get to here. This one would be 2 less months to get to here, and so on. 3 less months, 4 less months. So to figure this all out, I got to take one exponent off as I go. And I'm going to write this backwards just because it works out better if I do this. So then the next payment is going to only last 59 months. And so on backwards. I'm going to pause this and write this out. And if I take my last few payments, I'll have one payment that would be only lasting for 3 months, another one only lasting for 2 months, and then the last one that would only last in there for 1 month. I don't do 0 months because I don't put a payment in that last final stanza. Okay, so I have this situation here, and every payment in between as well. So if I look at this, and why I wrote this backwards is because if I do it this way, I'm building as I go on. If I wrote this one first, I would be actually dividing by a number, and I don't want to deal with that with this formula. So if I look at how do I get from this term to this term, well, I just take the exponent and bump it up 1, which means that I multiply by this factor, this growth factor, 1 extra time. Same thing here. I'm going to multiply by the growth factor 1 more time. Well, that growth factor turns out to be my ratio. Because if I took this term divided by this term, or this term divided by this term, the ratio would be 1 plus 0.04 divided by 12. That's my ratio. Oh, cool. Now, how do I get these other things? Well, my n terms, n is equal to 60. And then my a sub 1, well, that's going to be my first term. This is my a sub 1. So if I put this all into my formula here, s sub n now, which would be s sub 60, would be equal to the first term, which is 50, 1 plus 0.04 divided by 12. So that's just the a sub 1 there. And then I'm going to multiply that by 1 minus my ratio, which is 1 plus 0.04 divided by 12 again. The ratio is going to be raised to the nth power, and then I'm going to divide this all by 1 minus the ratio. And when you use this in the denominator, a common mistake that people do is they forget to put overall parentheses around the denominator. So plug it in your calculator, you get an error. See if you can try putting that into your, well, maybe I should just show you a shortcut to doing this. And remember, our goal is 3325 or 3326 if we're around it. What happens with our calculator is that it's a lot easier if I take this growth factor and I store it. So I'm going to go 0.04 divided by 12. My 12 didn't show up. So I'm going to do 12 and I'm going to store that into alpha A. So now instead of using that factor over and over again, I am just going to use the A variable there. So now if I put this into my calculator, I put the 50 and then A, which corresponds with my rate. And then I'm going to have 1 minus the R raised to the 60 and then divided by 1 minus R. And if I do that, look at that. Same exact answer as what I got off the spreadsheet and what I got off the calculator with the sequence formula. So for this one now, what we've done is we've shown you 3 ways to get the answer for this problem. Now you could put, with the spreadsheet, you could put in an additional initial amount, or with the calculator you can do as well. With the formula for the summation, though, we can't. Well, I guess you can, because A1 would be just a different term. So you could put in a different initial amount and work it out all 3 ways. Okay? So with this, we've done 3 different ways to look at this spreadsheet, the calculator, and then the summation formula, because this is a geometric. Geometric means that I have a common ratio, which we found to be multiplying every time by 1 plus 0.04 divided by 12. I hope this helps sort some of the issues out with what's the last term, what's not the last term, and I hope you enjoyed this. Have a good day.